Good morning, students. Today we will be doing the next part of the chapter rational number for class 7. In today's video, I am going to start with representing the rational number on a number line. So I have drawn a line, and suppose there is a question that I have to represent 3 by 4 and minus 1 by 4 on number line. So you have been working with number lines since your childhood. You know that we have to draw a line with arrows on both the ends because it shows that it is a number line. Now suppose I divide this line into different parts. I start with the center, which I mark as 0, and towards the right I have all the positive numbers, and towards the left I will have all the negative numbers. So suppose here I have to represent 3 by 4 and minus 1 by 4. They are both less than 1. So suppose I mark this side, right side is positive 1 and the left side is negative minus 1. So I have to divide the 0 and 1 and 0 and minus 1 into the number of parts, which is the denominator. Like here it has to be 4 parts, so that I can represent 3 by 4 and minus 1 by 4. So to divide it into 4 parts, I will make 1, 2 and 3. I will draw 3 lines. Actually it should be equal. So 1, 2, 3 and 4. So you can see there are 4 parts. Now these parts are 1 by 4, 2 by 4, 3 by 4. So I have to represent 3 by 4. So I put a dot over it. So I have marked the rational number 3 by 4 on the positive side. Similarly, to mark the negative side, towards the left of 0, I will divide again into 4 parts by making 3 lines. So 1, 2, 3 and 4 parts. So I have to represent minus 1 by 4, 2 by 4, 3 by 4. It is like this, but I have to represent minus 1 by 4. So this becomes my minus 1 by 4. Suppose in another question, I have to represent 7 by 3 on the number line. So I draw a line. Again, now 7 by 3 is not less than 1. If I divide, I can know it. So you'll see it is like 2 1 by 3, isn't it? So now the rational number is going to lie between 2 and 3 because it is 2 1 by 3. So I start with making a 0, then I make 1, 2 and 3, and this side I can just mark and keep minus 1, minus 2 and so on. So now it is positive and between 2 and 3. So I made a little spacious point. I have to draw how many, I have to divide it into how many parts? You can see 1 by 3, so 3 parts. So when I make 2 lines, 1, 2 and 3, I have 3 parts. So this one part is 1 by 3, this will be 2 by 3. So I have to represent 1 by 3. So this will become 7 by 3. So 2 1 by 3 will represent 7 by 3. Now by seeing this rational numbers on the number line, you will be understanding that all the negative numbers are lying to the left of 0. All the positive numbers, rational numbers, are lying to the right of 0. And if I compare any two rational numbers, whichever is in the left, generally that is a smaller rational number. So here I can say that minus 2 by 4 is less than minus 1 by 4. Or I can say minus 4 and minus 1 by 4 and 1 by 4. Because this is on the left, minus 1 by 4 and 1 by 4, I can say that minus 1 by 4 is less because it is towards the left of 1 by 4. And if I compare to positive rational numbers, 1 by 4 and 3 by 4. So as 1 by 4 is in the left side, I can say that 1 by 4 is smaller than 3 by 4. Now after understanding that, I'll take a little complex question. Here in this question, it is telling me to represent all these numbers on the number line. So how I can do it? You can see I have drawn a line with arrows on both the sides. Now to represent all the line, you can see that the denominator is different. Like here it is 8, 4 and 8. So what I can do is I can make all the denominators same so that I can easily plot the numbers. So if I take LCM of 8 and 4, it will be 8. So this is as it is. But 1 by 4 can be multiplied into 2 to be converted as 2 by 8. And then 7 by 8 can be just written as 7 by 8. Now all the three numbers have changed into the denominator base 8. Now you can see that negative number will be to the left of 0, and these two numbers, they are less than 1 because the numerator is smaller here than the denominator, and they will be towards the right of 0. So let us assume the center to be 0, this side to be positive 1 and the left side to be minus 1. So I have to divide these parts into 8 parts. So I draw 7 lines. Towards the left, seven. You see that you draw it equally distant using a scale. So all these lines represent 1 by 8. Positive side is positive rational numbers. I'm marking it to show you and to make you understand, and this side will be negative. Minus 1 by 2, minus 2 by 8, minus 3 by 8. And this one is minus 7 by 8. Now I have to represent minus 3 by 8. So you can see where is minus 3 by 8. Just put a dot over it. You can also name the points here. Like I call it P, suppose. And then 2 by 8. 2 by 8 is here, because that was 1 by 4. The standard form was 1 by 4. So I've changed all the bases into 8 denominators. So this will become, suppose, Q. That is 2 by 8. And suppose I name this as R. So you can see 7 by 8 is here. So you can see I've made all the rational numbers. I have represented them on the number line. So if you have such a question, you can see if you can make the denominator same. Generally you will have questions which can be easily converted into the same denominator. So convert the denominators into the same number and easily plot the number line. Now we will learn how to compare the rational numbers. For example, you have got a question which is greater. You have to find out whether minus 4 by 9 is greater or 5 by minus 12. So when you see a denominator with a negative number, please first convert it into a positive number. The denominator should be positive. So how do I do it? It's 5 by minus 12. I multiply a minus 1 to the numerator and the denominator. So it converts into minus 5 by 12. Now I'll compare minus 4 by 9 and minus 5 by 12 because they are the same. Now this 5 by minus 12 and minus 5 by 12 becomes the same. So let us compare minus 4 by 9 and minus 5 by 12. If you remember fractions of class 6, you will be easily knowing that when we have two rational numbers which are like the fractions only, 9 and 12, I need to calculate the LCM. So the LCM of 9 and 12 will be 36. You can calculate it. And now I need to convert the denominator and the numerator into such numbers which are called the equivalent fractions. So how do I do it? So for minus 4 by 9, I can convert 9 into 36 by multiplying 4. So I multiply same number in the numerator. And then minus 5 by 12 into 3 will give me 36. So I do a 3 minus 3 in the numerator also. So it becomes minus 15. So now you have two numbers or two rational numbers, that is minus 16 by 36 and minus 15 by 36. Just now I told you in the number line that when we are having a number to the left On the number line, if I will be representing, you know that minus 15 by 36 will be first, and then minus 16 by 36. So the number on the left is minus 16 by 36, which is smaller. So what is the actual fraction for this? The actual fraction for this is minus 4 by 9. So that will be lesser than minus 15 by 36, the actual fraction of which is minus 5 by 12. So I can say that minus 4 by 9 is smaller or lesser than minus 5 by 12, because minus 5 by 12 is greater. So minus 4 by 9 less than minus 5 by 12. Similarly, you can get questions like fill in the blanks with the greater than, less than, or equal to symbol. So here it is minus 7 by 8 and 42 by minus 48. So again, as I told you, first make the denominator positive, so it will become minus 42 by positive 48. If we calculate the LCM, you will get 48. So how can I make 8 into 48? By multiplying 6. So I multiply 6 on the numerator as well. So now you see that I get minus 42 by 48, and this is minus 42 by 48. So are they different? No, they are same. So I will put a equal to sign in this box. So I hope you are able to now compare the different rational numbers. It's very simple logic. Now we will learn how to arrange the rational numbers in descending order. So I have been given some rational numbers, and descending order means from bigger to smaller number. So first you can see there is a denominator with negative number. So first thing that you have to do is to convert that into positive by multiplying minus 1 into numerator and denominator, which will convert it into minus 70 by 30. Now you have to take the LCM of numbers 10, 20, 15 and 30, which you will get as, let us see, I'll show you how I'm doing it. 2s are 5 and 10, 15 and 15. Again 2s are 5 and 5 and 15 and 15. 3s are 5, 5, 5 and 5, and then 5s are. So 4 into 3, 12, 12 into 5, LCM I'll get is 60. So my motive will be to convert all the denominator to base 60 and also multiply the equivalent number on the numerators. So minus 3 by 10 into, so minus 3 by 10 into what will give me 60? So 6 in the denominator, so same in the numerator, that is minus 18. Then minus 11 by 20. So how can 20 convert into 60? By multiplying 3. So this is minus 33. Then minus 5 into 15. So into 4 can give me 60. So into 4 in the numerator, that is minus 28. And minus 17 into 30. So 32s are 60. So 17 2s are minus 34. So I've got all the rational numbers with the same denominator 60. Now you know that as it is negative number, all the rational numbers here are negative. The one with the smallest numerator, the one with the smallest numerator will be the largest number. So we have to arrange in that sequence. So it will be 80 by 60, then minus 28 by 60, then minus 33 by 60, and minus 34 by 60. So what I can write, the actual representation is 3 by 10, minus 7 by 15, minus 11 by 20, and minus 17 by 30, or the actual question was 17 by minus 30. So now this becomes the descending order. So what have I done? Calculated the LCM, converted all the rational numbers into the equivalent fractions, then compared the numerators. The smaller numerator is the one with the larger number because it is negative. If it was positive, then we would have done like normal fractions, we would have treated them and arranged. So this is how you can arrange the rational numbers in descending and ascending order. Our next part is inserting the rational numbers. So how do I insert rational numbers between the given rational numbers? So let us try the first question to understand it. So insert 5 rational number between -3 and -2. So some of you might be thinking that how is it a rational number? So it is that I can represent it as -3 by 1 and -2 by 1. So I have to insert 5 rational number. According to the rule, when I have to insert n numbers of rational number, here n is 5, so I have to add +1 to it. So I will add +1 and get 6. Then I need to multiply that number with the denominators. So 5 numbers to be inserted, so n plus 1 becomes 6. Multiply the denominator of these numbers by 6. So I get -18 by 6 and -2 by 1 into 6 numerator and denominator becomes -12 by 6. Now between -18 by 6 and -12 by 6, I am having a number of rational numbers. What are those? In between these two, I am having -17 by 6, -16 by 6, -15 by 6, -14 by 6, and -13 by 6. So these numbers I can use direct. These two numbers I cannot reduce, but these I can reduce. So whichever can be reduced, always write in the reduced form. So this can be divided by 2, I can get -8 by 3. This can be divided by 3, I will get -5 by 3. This can again be divided by 2, I'll get -7 by 3. So the numbers in between these two rational numbers will be the following set. So what we do, we see how many we want to insert, add 1 to it, multiply the denominator with that numbers, and in between these two rational numbers which are having the same denominator, we get the required rational numbers. It can be even more and different for each one of you, but this is the logic of completely solving this question. I'll give you one more example. Suppose it is asking you to insert rational numbers, 3 rational numbers between -4 by 5 and -2 by 3. You can see here the denominators are not same. So the first thing that you do is LCM of 5 and 3 you calculate so that you have the same denominator. So it becomes 15. Now 4 by 5 can convert into 15 denominator by multiplying into 3. So this becomes my number. And 2 by 3 can convert into -10 by 15. Now in between them there is only one rational number, as you can see, that is -11 by 15, but I need 3 rational number. So according to the rule, n plus 1, so that is 3 plus 1, I'll multiply it with 4. So -12 by 15 into 4 and -10 by 15 into 4. So I get -48 by 60 and -40 by 60. So in between them we are having -47 by 60, -45 by 60, -44 by 60. I need 3, so I take any 3, and these I can even reduce. 15 3s are and 15 4s are. 22, 30, 11, 15. So I can write -47 by 60, -3 by 4 and -11 by 15. So convert into the same denominator, take out the LCM. How many you want to add, that many rational number plus 1, make it into the same denominators, and then in between whatever numbers are there, you can use them as the rational numbers. So I am very sure with all this you will be able to solve your exercise, and I hope you have understood the topics I have discussed today. I would like to request you to like, share and comment and tell me whether you have understood the questions and what should be my next topic. If you want any particular topic to be discussed between any subject of science and maths from class 6 to 8, you can let me know. Thank you.